Let's have a look at the reaction mechanism of aldehyde and ketone with the cyanide group. The reagent required for this reaction is hydrogen cyanide, or you can use mixture of sodium cyanide and sulfuric acid. As when you use sodium cyanide and sulfuric acid, eventually it will produce hydrogen cyanide, and hydrogen cyanide would be the reactive species in the reaction. So you can write down either of these and it's still correct. The condition is reflux. Now if I look at the hydrogen cyanide, it's a weak acid. It dissociates partially to give out H plus and Cn minus ion. Now this Cn minus acts as a nucleophile because it has lone pair of electron which can be donated. When I look at the aldehyde molecule, the situation is oxygen being electronegative, pulling the electrons towards it from the covalent bond, and therefore it's developing delta negative charge. Carbon has got delta positive charge. The cyanide lone pair electron attack on the carbon delta positive, which is a nucleophilic attack. In the next step, as the oxygen pulling the electron, it breaks the pi bond because it's much weaker than the sigma bond, and you may need to find out why. It develops the negative charge, and cyanide coming in, which make the additive covalent bond here, and hydrogen. So the cyanide is used up. In the reaction mixture, you have acidic condition, and that will give H plus ion. So that H plus is here. The lone pair of electron get attracted towards the hydrogen plus, forming the compound which has got OH group, that is the 1, and it has got the Cn group, which is called as a nitrile group. So remember, it's a nitrile group. Now as you got the OH and nitrile, so the nitrile group will take the priority, and therefore the OH group will become hydroxy in the naming. So when I look at this compound, what I find here is it has 3 carbon, and we started with, so here it has got 3 carbon, we started with 2 carbon. So this is very important that when we carry out the reaction of aldehyde or ketone with cyanide, it increases the carbon chain by 1, and that is one of the most crucial thing when you design the drug. Now if I name the compound, it's a 2-hydroxy, 3 carbon, therefore it's a propane, and nitrile is the functional group. The type of mechanism is, it's a nucleophile and it's being added, so therefore it's a nucleophilic reaction. On the top of that, you need to think that whether it's a addition reaction, substitution reaction, or elimination reaction. Now for that, you always focus on the final product. When I look at the final product, I can see that, well, it has only one product, so it's a classic way defining the addition reaction, so therefore it's a nucleophilic addition reaction. That's it really.